Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. Today we are going to study in this session the velocity and acceleration analysis of a 4-bar chain by taking an example. This is the example I consider from one of the standard textbook. So here PQRS is a 4-bar chain link. With the link PS is fixed. The lengths of the links are PQ, that equal to 62.5 millimeter, and PQ equal to 62.5, and QR 175 millimeters, and RS equal to 112.5 millimeters, and PS equal to 200 millimeters. The crank PQ rotates with an angular at radians what is 10 radians per second in clockwise direction. Draw the velocity and acceleration diagrams when angle QPS equal to 60 degree and Q and R lie on the same side of PS. Find the angular velocity and angular accelerations of QR and RS. We want QR and RS. We want angular velocity of QR and angular velocity of RS, and also angular accelerations of QR and RS. So in this problem, in this sum, it is mentioned that we need both angular velocity component, angular acceleration components, and so that what to do? We have to draw velocity diagram and also acceleration diagrams. Then only we can solve the objectives given in this problem. Now here, based on the given data, first we have to draw the configuration diagram or space diagram in our answer script with a given dimensions. Now what are the given dimensions given? So omega QP, that equal to 10 radians per second. That is QP is it is acting as a PQ link. Then what is the length of PQ? That is 62.5 millimeter. That converts into meters. Then it becomes 0.065 meters. QR is 0.175 meters. RS is 112.5 millimeter, or 0.1125 meters. PS equal to 200 millimeter, or it is 0.2 meters. With a given geometry, we have to draw the space diagram. The space diagram is obtained like this. Now, from this we know what is the velocity from QP. What is the linear velocity of the link PQ? That equal to VQ equal to omega QP times PQ. What is omega QP? That is 10 radians per second times PQ length. That is 0.0625 meters. Then equal to 0.625 meters per second. We don't know the remaining values. We know the directions, but we don't know the magnitudes of the other links, that is QR and RS. Alright, QR and RS we don't know, but we know the magnitude and direction of the link PQ, and PS remains fixed. That means we have to keep these two letters P and S at one position, PS at the one pole. Then we have to start drawing. Let us start drawing. How to draw? With the known values, we know the vector PQ, that is velocity vector QP, that equal to VQ, that is 0.625 meter per second. Then you convert this 0.625 meter per second into some suitable scale, that is vector scale. Then draw the vector line, that is P and S, place at one point. Then draw a P and S are fixed points. All fixed points you keep it. Fixed links points keep it as a one pole. Then draw a line perpendicular to the link PQ. This is a vector line. Then remaining QR and RS. This QR and RS, we know the direction, but we don't know the magnitude. Magnitudes are unknown. Those unknown magnitudes are to be found with the help of velocity diagram. So then join, that is step 1, first step. Then draw a line perpendicular to the link QR from space diagram. That is the QR line. Then this QR line keeps, we don't know the length, you draw how much. Then after that, draw a line perpendicular to the link RS. From S, draw a line perpendicular to the space diagram line of RS. Then it will intersect at the point R. Now if you measure this vector length RS denotes velocity of the R, and this RQ denotes velocity of the link QR. Why it is RQ here? This RQ is QR is not connected directly to the fixed link. Whereas VR, this R is directly connected to the fixed link. That's why velocity of R with respect to S, that is VRS. This VRS, where S is a fixed link, is nothing but velocity of the R, absolute velocity. In this, how many absolute velocities are there? This RS is one of the absolute velocity, and the Q point connected to P, that is the VQ, is another absolute velocity. VQ is another absolute velocity. And QR, this QR is relative velocity. This QR is a relative velocity. That is a VQR. Okay, that means VQ and VR both are absolute velocities, and VQR is the only relative velocity in this. In this only it is a relative velocity. So what we want, we know the linear velocities. Then what is the linear velocity? V equal to R omega. Omega equal to V by R. Suppose if you want VRQ we know, then omega QR. Then omega QR means VQR by QR link. What is the VQR by QR? VQR by QR. Now here VQR, we know that omega QR. Omega QR, what is the VRQ value? The VRQ value is 0.33 we measured from the vector diagram, velocity diagram. And RQ is what is the length of the QR link, that is 0.175 meters. Substitute over here, then we can know the 1.9 radians per second value. Next, that is 1.9 radians per second. So you can, what is the direction of this angular velocity VRQ? It is in the same direction of the linear velocity. So if you see in respect to S, fixed link, the direction is what? Counterclockwise direction. That's why it is a anti-clockwise. Sometimes in some of the textbooks, they will make mistake that it is in clockwise direction. No, it is in anti-clockwise direction. You can see it is counterclockwise direction. Next, velocity. Next, we want angular velocity of the link RS. Angular velocity of the link RS equal to linear velocity of the link RS by length of SR or RS. That is linear velocity of the link. What is SR is there? The vector SR length. that is 0.426 meter per second by SR link is 0.1125. Then it is 3.78 radians per second. Now this RS is moving with respect to S. It is in this direction, clockwise direction. That is clockwise. The direction of the angular velocity, the direction of the angular velocity of the link RS is in clockwise direction. The value is 3.78 radians per second. Okay, now those are the values. Next objective, there are two are there. That is angular accelerations of links QR and RS. We want angular accelerations. Angular acceleration means alpha QR and alpha RS. This alpha QR, alpha RS comes from where? We want tangential components of QR and tangential accelerations of RS. Okay, how to find out? Now we have to draw the acceleration diagrams. From that acceleration diagram only we can calculate this angular acceleration of links QR and RS. So how to start? First of all, before going to start the acceleration diagram, first whatever data we know from velocity diagram, from that you write down or you calculate the acceleration components, whatever we know acceleration components from the velocity diagram. From the velocity diagram, V square by R, that means from this radial components can be found for all the links, definitely from the acceleration diagram. What are the radial components are? Now we know the magnitude and direction of the radial components, but we don't know the magnitudes of tangential components, but we know the direction of the tangential components of all the links. How? Because it is normal to the radial components. That's it. Now, the radial components, whatever data we know, based on the data observed or obtained from velocity diagram. Now, ARQP. This ARQP, that means here, this 60 PQ is having constant angular velocity. That means if it is constant angular velocity, what is the tangential component? 0. What is the total acceleration? Total acceleration equal to radial acceleration plus tangential acceleration. But in this case of PQ, that radial acceleration component only existed. Tangential acceleration is 0. Then the total acceleration of the link QP equal to radial acceleration. That is AR equal to AQP, that equal to AQ equal to V square QP by PQ. What is the VQP? V value 0.625 whole square by PQ 0.0625. That is 6.25 meter per second square. That is PQ over. We want radial component of next link. What is the next link is? Q is connected to R. QR. That is ARRQ, radial component. What is the radial component? VRQ square by QR. V square RQ. That is VRQ measured here. That is 0.33. 0.333 whole square by 0.175. 0.634 meter per second square. Next, we found PQ radial component, QR's radial component of acceleration. Next, RS. What is radial component of link RS? That is ARS equal to AR, that equal to V square RS by SR. That is 0.426 whole square by 0.1125. That is 1.613 meter per second square. These are the known values. ARQP that equal to AQP that equal to 6.25 meter per second square. These are the known values. With these known values, we are going to draw the acceleration diagram. How we have to going to draw the acceleration diagram? Yes, let us begin. First point is that mark your point P. That is pole. The pole, at the pole, all fixed points should be there. what is the fixed link here? P and S. That is, in the case of acceleration diagram, the notations are P dash, S dash, like that, R dash, Q dash, like that. We are using dashes. As we will draw in front view, top view, notations will change it in order to find out or discriminate the things. Now, the point is that, next, how to find out here? Let us begin. P dash, S dash. This is the first step. P dash, S dash. P dash, S dash. After that, P dash, S dash, make it one point. That is P dash, S dash here. Let us begin. In P dash, S dash, 2 connected PQ. What is the PQ? We know the PQ directly. That is nothing but AQ. Convert this acceleration scale to vector square. You convert that some 0.25 meter per second square equal to 1 centimeter, assume. Then you can find out how much is 6.25. So our 0.5 meter per second square equal to 1 centimeter. Then it becomes easy. Okay. Whatever values will come, that with a suitable scale, draw a line. Which line? That is total acceleration. That is, if you draw a line, that is PQR. This is P dash Q dash. Draw a line. What is the length? The length is 6.25 meter per second square in a vector scale. That is which component? The total acceleration is a radial component. Radial component should be in the line of, parallel to the direction of the link PQ configuration. This is PQ and P dash Q dash, both are parallel lines. Okay, next. What is the next step? Q is connected to which link? R. QR dash, if you want, Q dash R dash. This total acceleration consists of 2 components. First component is radial. What is the radial component? That is Q dash X. With a known value, that is, what is that? RQ, no? That is Q dash X. What is the radial component? That is 0.634 meter per second square. That is Q dash X. With this scale, draw a line parallel to the link QR. We are drawing the radial component. This is parallel to the QR. After that, with this QRQ, this tangential line is tangential. We don't know. This is the tangential. We have drawn. This is normal to the radial component RQ. Next step. Coming to at S dash. SRS. This RS is again consists of 2 components. One is radial component. We know the radial known value. That is 1.613 meter per second square. Convert this 1.613 into suitable scale. That is radial component. So draw a radial line. Next step. That is with the known value, that is Y. Then what is the tangential component? Normal to the radial component. This is the normal line. Both will intersect at one point, that is R dash. Next, what step we want? We join Q dash to R dash. That is the total acceleration of Q dash R dash. That is ARQ. Then you join R dash S dash. S dash to R dash. Then that value gives R dash S dash gives the acceleration of AR dash S dash, that is AR. Okay. Now, what is the first step again? You measure the vectors, then you can know what are the values you want. If you measure R dash Q dash, that is acceleration of ARQ link. Next, if you join R dash S dash, that is acceleration of AR or ARS. Because S is the fixed link, that's why AR. That is absolute acceleration. How we have done? What is the step number 1? Step number 1 is, what is the step 1? P dash Q dash. Step number 2, RQ. Step number 3, AT RQ. Step number 4, AR, RQ, AR, why this is called S, AR, RS. Step number 5, ATRS. Step number 6, this R dash marking. Step number 7, join R dash to S dash. Step number 8, R dash to Q dash. Then after that you measure, then you can know required. Even though whatever they ask objectives more than that, you can find out based on this velocity acceleration diagram. Okay. In the velocity diagram, what is the step 1? VQ is the step 1, VRQ step 2, VR is the step 3. Now after knowing this, you can find out we want angular acceleration of the links, alphas. What is the angular acceleration of link? Angular acceleration of the links QR and RS. What is the QR angular acceleration? This is the total acceleration AT RQ we know. AT RQ means X R dash is the RQ. X R dash value that gives AT RQ. AT RQ means RQ times alpha. This alpha RQ comes. Again I am showing you here. First step I am going to show you here. This is step 1. The known values of AQ. This is second step. That is RQ. Next, third step is ATRQ. This ATRQ we don't know dimension, we know only magnitude. We know only direction, we don't know the magnitude. The fourth step is ARRQ. These are the known values. Fifth step, this is unknown magnitude but direction we know. Sixth step, this is the sixth step, marking R dash. We considered it before, that sixth step. This is what sixth step here, join. It is the seventh step, ARRQ. Thus we can find out completely. So very simple in acceleration diagram. Provided you have to keep it ready data, whatever known values we are having from velocity diagram. So as I shown you here, that is the steps here I mentioned. Okay, in order to find out the various letters of various values of tangential and radial acceleration components of various links. Okay, now here since P and S are fixed points, in this slide you can know the data exactly what is required for you. Everything is mentioned and you can measure it. What is the ARRS? That is Q dash X. Q dash X is RQ, that is 0.634, and ARRS. This is the value RS, that is 1.613 meter per second square. Okay, then after getting this, what to do? Okay, after getting these values, you measure, find out. We want alpha RQ and we want alpha RS. Alpha RQ and alpha RS. So for that we need ATRQ measure. What is that ATRQ is? X R dash vector, that is 4.1 meter per second square. Okay, and ATRS is 5.3 meter per second square. Then alpha QR equal to ATRQ by QR. From that 23.43 radius per second square is observed. That is angular acceleration of the link RQ. Next RS, that RS equal to ATRS by RS. That ATRS is 5.3, RS is 0.1125, then it is 47.1 radians per second square. How can we know it is clockwise or counterclockwise? You can see with respect to the fixed point or the direction of rotation. The direction of rotation is, it is in clockwise direction. They mentioned here RQ is counterclockwise. Okay, no, it is in clockwise direction. And Yeah, that is ARRQ, whereas ARRS, what is alpha RS is alpha RS, that is in clockwise direction. So here they mentioned both are in clockwise only here. Okay. Now that is the way one can mention it, all the points, all the acceleration components. Okay. The final values are ARRQ, ARQP and ARRS, all these known values. Okay. Very important. Again, let me conclude that in this problem we considered the case study of a 4-bar chain. 4-bar chain, and always remember very important configuration diagram as it is you have to copy with either reduction scale or maximum scale in the answer script. Beside that you have to draw either left side or right side, either top or bottom, in such a way that you can use either set squares or mini drafter. You have to draw velocity diagram, which should be the beside. It should be away also, but you need set square. The size of the set square are required larger. And similarly, and acceleration diagram also it should be beside velocity diagram, or it should be beside the configuration diagram or space diagram. So, and again, acceleration diagrams, values depends in our, if we want to draw or to draw acceleration diagram, we need the values of velocity diagram values. And we, in order to draw the velocity diagram, we need a space diagram. So that if in the question, draw the velocity and acceleration, that means it is a package. You have to draw again space diagram also. So if they ask only acceleration diagram, we have to draw velocity and space diagram. If they ask you to draw velocity diagram, we have to draw the space diagram. So space diagram is must and should for both velocity and acceleration diagrams. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.